exciting episode of 6th grade math with your host, Mrs. Fernley. Yay! Everybody clap. Okay, so today we're working on functions and equations. And actually, with this lesson, it kind of helps understand yesterday's lesson, because I know it was a little bit difficult. All right, so our essential question is, how does the data in a function table get used to create the graph of a function? All right, there's only one vocabulary word, and that is linear function. So a linear function forms a line on a graph. That's it. Okay, so a linear function is going to form a line. Linear meaning line. And then function, of course, is the equation that we're working on. All right, so find the equation of the data table. Okay, so the equation is just a fancy name in math for the rule. All right, here we have input, and output. All right, and here is the data. All right, so I have 1 and 9, 2 and 18, 3 and 27, 4 and 36, 5 and 45. All right, so getting from 1 to 9, I can add 8 or I can multiply by 9. If I add 8 to 2, that doesn't give me 18. If I times 2 by 9, then I get 18. So multiplication works. So my equation is 9x equals y, right? Because this is x and this is y. So 9 times x equals y. So that is actually the equation. It's just pretty much adding on the equal sign and the y. Because remember, an equation requires an equal sign. Before that, our rules have just been expressions. All right. Okay, so that is how to do the equations. You're just going to make the rule into an equation. Get the equal sign, and it's either x or y, but more times than not, it's y. All right, so now we're going to graph. All right, so we had the equation 9x equals y from up above. All right, and now we've got to graph it. So I'm going to graph the equation 9x equals y using the information from above. So I'm going to have all positive numbers, so I'm just going to do an L graph. So this is my y value, this is my x value. And since I'm going up to 45, 5, 10, 15, 20, 25, 30, 35, we'll guesstimate where 45 is. So I want to count by 5s. Or I can go 10s, 10, 20, 30. Yeah, let's go 10s. So 10, 20, 30, 40, 45. And then my x values were 1, 2, 3, 4, and 5. And I'm just going to plot the points. So if you're looking at the data table, my first point on X was 1, and then my Y value was 9. So I'm going to go 1 and 9. I'm going to put a dot right there. Okay. My next one was 2 and 18. So I'm going to follow 2 up to 18, which is almost to 20. 3 and 27. So 3 and 27, which is almost 30. 4 and 36. So 4 and 30. Oops, this should be 50. Apparently I can't count by tens. All right, so 4 and 36, so that's going to be like right here. And 5 and 45. Going to be right here. All right, and see how it makes a straight line? That is a linear equation. All right. Okay, so I had to record this again because I was way wrong. So if you can't get from X to Y, then you need to use the scale table. We did this in chapter 6 when we didn't know how to get from one value to another. So I don't want to use 1 and 20 because that's going to be a little bit too confusing. So I'm going to choose 2 and 25. So I have 2 here. And I need to get to 25. Okay, look familiar? All right, so I'm going to do something here, and then I'm going to do that to here. Okay, so multiplication or addition because I'm going up. So I need to get from 2 to something and from 5 to something. All right, so how can I do that? Let's think about it. All right, if I go, let's see, let's find out the factor tree, 2 and 25. Well, 2 is already a prime number, so this is 5 and 5. Okay, so I can use one of these 5s, right? If I go 2 times 5 is 10, but I can't multiply anything to get from 10 to 25, but I can add 15, right? So let's see if it works for one of the other ones. Let's go 4. All right, so if I do 4 times 5, which is 20, and then I add 15 to 20, that gives me 35. Okay, so there is my rule. So now I'm going to do 5x, right? Because I multiplied 5 times 2, and then I'm going to add 15. So that makes it way easier on what you guys were working on last night and today. All right, so let's do one more graph. We're going to graph this one. You're going to need some room, so make sure you have some room. I want to graph 2x plus 0.5. Yes, we can do the same thing with decimals. Okay, so let's make my table. So I have x, and then y. And I already know my rule, right? 2x plus 0.5. All right, so first value for x, actually let's do all the values. 1, 2, 3, 4, 5, 6. So I'm going to go 2 times 1 plus 0.5. So 2 times 1 is 2 plus 0.5, I should have 2.5. 2 times 2 is 4 plus 0.5, I should have 4.5. 3 times 2 is 6. So 0.5, I should have 6.5. Get the picture? I'm going to have 0.5 ending in all of them. 4 times 2 is 8, so it's 8.5. You can see the pattern. 5 times 2 is 10. Add the 0.5, so it's 10.5. 6 times 2 is 12, so I get 12.5. Okay, so if I was to graph that, I have all positive numbers. And since my highest number is 12, I can count by 2s. So let's do that. So this is 0, 2, 4, 6, 8, 10, 12, and go 14 just for prosperity. Then I have 1 through 6 for my x-axis. All right, now I just graphed the ordered pairs. So 1 and 2.5. So 1 and, oh my goodness. And 2.5 is going to be like right here. I'm a liar. That's less than 2. Okay, so 2.5 is going to be like right here. Okay, 2 and 4.5. So 2 and 4.5. 3 and 6.5. 4 and 8.5. 5 and 10.5, and 6 and 12.5. Makes a line. Linear function. All right, so you'll probably have another handout for this for homework. It is not due until Monday, but I would prefer to have the knowledge check done at least this weekend, if not sooner. That way I can analyze it and see what group you're going in. So, all right, you guys have a good night.